Hi everybody, today I want to share with you President Garfield's proof of the Pythagorean Theorem. The Pythagorean Theorem says in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if we make the height a and the base b and a hypotenuse of c, we have a squared plus b squared is c squared. What I'm going to show you in this video is a step-by-step explanation of how James Garfield proved the Pythagorean Theorem in 1876. There are other proofs of the Pythagorean Theorem, but this is the one I've always liked to use. So we'll start with a right triangle, and we're going to duplicate it. After we duplicate it, we're going to flip it around, and we're going to line the two triangles up, forming a straight line. That's important. To help with clarity, let me add on where the right angles are at, and let's add some labels to the triangle. I'm going to call the original height of our triangle A, which means it's also going to be at the top of our new triangle. Then I'll call the base B, which makes the base B also straight above A on this line we just formed. Our hypotenuse is going to be C, and again we have that twice because we have two triangles. Then here's a key element of why Garfield's proof works. He turned these two triangles into a trapezoid. And by definition, in a trapezoid we always have two parallel sides. Let's move that shape over to the right. Let's label the sides of this trapezoid. We'll still have B at the bottom, A at the top. The left side will be A plus B, and I don't really need to know the right side. Now that we have these shapes, we want to show that the area of these shapes are equal. Let's write in the area of a trapezoid. It's 1/2 base 1 plus base 2 times the height. The height is perpendicular to the two sides that are parallel. The area of a triangle is 1/2 base times height. And in the left side, I really have three triangles. I have the original triangle I started with, the one I duplicated, then the new one that was formed by adding in a side between the two triangles. The area of our original triangle is easy to find. It's 1/2 base times the height, so 1/2 b times a. Because our second triangle is just a duplication of our original one, we now have 2 times 1/2 b times a. So the only thing missing is the area of the new triangle we formed. The only thing we know right now is 2 of the sides are c. If we call the angle formed by b and c theta, then we can label that it's on the triangle twice. The angle formed by a and c would be 90 minus theta because we know these two angles are complementary. A and B form a line, which means it has 180 degrees. So let's take a quick look at the angle alpha that's formed by the intersection of the two sides C and C. We know that theta plus alpha plus 90 minus theta equals 180 degrees. Theta minus theta is going to cancel, which means alpha plus 90 is 180. If I move the 90 to the right, that says alpha is equal to 90 degrees, which says my new triangle is also a right triangle, which we can easily indicate on our shape. This is helpful because if we know this is a right triangle, we have a base of c, a height of c, which means we have an area of 1/2 times c squared. So these three triangles together are equal to the area of our trapezoid, which we can write as 1/2 the sums of the parallel sides A and B times the height of A plus B. The first thing I can do is multiply 2 times 1/2, and instead of having BA, I'm going to switch that to AB. Now I have AB plus 1/2 of C squared is 1/2 of A plus B squared. Let's clear those fractions by multiplying everything by 2. Now 2AB plus C squared is equal to A plus B squared. The left side looks good. We want to expand the right. Remember, when you square a binomial, you get a trinomial. A plus b squared is equal to a squared plus 2ab plus b squared. Notice now I have a 2ab on the left, a 2ab on the right. Those two cancel. This gives us c squared equals a squared plus b squared, which is Garfield's geometric proof of the Pythagorean theorem.